So as we go through these lessons, you can work on filling in your notes for the probabilities, so 7b. And so as you guys are going through the PowerPoint, you'll see that the first type of probability that we're talking about is an AND probability. And probabilities is always a multiplication. And so we want to find out the probability of rolling 2 dice and getting a 6 and a 1. So we have to have 2 dice in order for that to happen. And also rolling 4 6s. And so we're going to probability of rolling 1 6 or a 6 is 1 out of 6. And the probability of rolling a 1 is also 1 out of 6. And because and probabilities are multiplication, we multiply these, and 1 out of 36. And again, we can write probabilities in terms of their fraction, a decimal, or their percent. And so 1 out of 36 is, as a decimal, is 0.00. And then 1 out of 36 as a percent is going to be, it's 0.03, or it's 2.8%. And then 4 6s. Now it doesn't matter if we have 1 dice and roll it 4 times, or if we have 4 individual dices. So we get 1 out of 6 times 1 out of 6, 1 out of 6 times 1 out of 6, which is 1 out of 1296. This is also 0.00. .08%. So if we look at the next set of, so we have a special type of independence, the at least, and at least is just a formula where it's 1 minus the probability that it doesn't happen, raised to the number of times we're trying to do this. So at least a 5, rolling a 5 in 7 tries. So not rolling the 5 is 5 out of 6. So 1 minus 5, 6 raised to the 7th power. You just type that into your calculator. So then we have the AND probabilities, which are dependent. So you can think about eating M&Ms, because you're not going to replace them back into the bag. So when they're independent events, they are with replacement, or they don't depend on each other. Dependent events, they depend on each other. And so we're going to find the probability of 2 brown and 1 yellow M&Ms, and then a different one where we're going to find the probability of 3 men. So we want to find the probability of 2 brown, and so we have 16 total brown, and we have 7 yellow. And so 16 out of 50, when you count them all up, you get 50 times. Now that you're going to eat one, you ate the brown one, and you ate one of the candies, so now we only have 49. And in terms of the yellow, we have 7 yellow, so we still have all 7 yellow in there, but now we only have 48 candies. And then we can write this also as a percent or a decimal. If we have, so you can finish that up, we have 3 men. So let's look at our committee of 3 men. And that's understood to be a dependent event, because once you pull out a man for the committee, you're not going to put him back in. So even though it doesn't specifically say anything about without replacement, you can assume that, just like you can also assume that you're going to eat the M&M. So if we want 3 men, we have a total of 9 men and 12 women. So we have 21 total people, and we have 9 men out of 21. Once that 1 man is picked, now we have 8 left, only 20 people to choose from. 7 men left, and 19 to choose from. And again, multiplying that out, and then we can either write it as a decimal or a percent. With OR probabilities are going to have addition as its operation, and there's always a higher probability if it's an OR probability than it is with an AND probability, because these things, this or this or this, And so when we talk about non-overlapping events, we're talking about things that are mutually exclusive. They cannot happen at the same time. So examples, giving birth to a boy and a girl cannot happen at the same time. If you're playing rock, paper, scissors, you can only have one of those, or heads or tails. So we want to be, an example of this is if we have 2 dice, and we want to get the sum of a 2, the sum of a 3, or the sum of a 4. And so these things, getting those could only happen, they're not overlapping. You can only get the sum of a 2, you could only get the sum of a 3, or only get the sum of a 4. So if you refer back to the table that I gave you that went with this worksheet, you can see on there that there's only 1 out of 36 outcomes to get the sum of a 2, plus we can get 2 out of 36 outcomes to get a sum of a 3, and 3 ways to get the sum of a 4. And so we end up with 6 out of 36, which is 0.17 or 16.7% chance of that happening. Then we have what we call overlapping events, and so these things happen at the same time. So we like to use Venn diagrams to show where things overlap. You may have used these in an English class when you were doing a compare and contrast paper. So all the cards in this circle are black. All the cards in this circle are 7s, and we know that there are 2 black 7s. And so if we counted all the cards here and counted all the 7s here, we're going to double count the black 7s, so we're going to have to subtract those out. So if we want to find the probability of a black card or a 7 card, there are 26 black cards out of 52. There are 4 out of 52 7s, so we're doing the same thing that we did over here, except now we have to subtract out the fact that we had the double count. So this is our double count. So we're going to end up with 28 out of 52 ways for that to happen. So in the next problem, we wanted to do, if we wanted the probability of a woman or an American, so we want to find out how many women there are. So we have 20 and 25, so we have 45 women. So we have 45 out of 90. Plus, now we want to find out how many Americans we have. And so we have 25 and 20, so we have, again, 45 out of 90 Americans. Minus, we want to know how many American women there are, and there's 25 American women, so we're going to subtract out the 25 American women to come up with our answer.